and welcome to this episode of Night Sky News for March 2026 with me, astrophysicist Dr. Becky Smethurst. This is a show where we chat about what you should look out for in the night sky in the next few weeks, and then we chat about what's been happening in space news in the past few weeks. In this episode, we're chatting all about the new alerts from the Rubin Observatory that's got the astrophysics community very excited, along with the scientific programs that have been awarded time to use the James Webb Space Telescope, plus the new class of exoplanet that's been discovered, plus whether we've spotted the first evidence of material transfer between two asteroids, evidence that could help support the idea of panspermia, the idea that life could travel between star systems in the universe. There's chapter markers down here if you want to skip ahead to any specific news story, plus any scientific research papers I mention are all going to be linked in the description down below, free to read. So, without any further ado, let's kick things off, and start by looking up. So it's official, we made it through winter here in the Northern Hemisphere because we have just passed the official start of astronomical spring with the equinox on the 20th of March, the day which marks the switch between which hemisphere of the Earth is leaning towards the sun. Now you'll usually hear people describe the equinox as the day that we have equal daytime and equal nighttime, but that's not quite true. That's what's known as the equilux, and it always happens a few days earlier than equinox. Now the reason it's a few days earlier is because of refraction. When the sun's light comes in from space, it hits the top of the Earth's atmosphere and bends. It changes its path slightly. So a fun fact, when you're watching a sunset, the sun is technically already below the horizon, but you can still see light from it because it's bent through the Earth's atmosphere. That means that on the equinox, when everything is perfectly aligned and the Earth's axis is 90 degrees to its rotation around the sun, which should give us 12 hours of day and 12 hours of night, the sun actually appears to be above the horizon for a few extra minutes at sunrise and at sunset, making the day ever so slightly longer than 12 hours. All this to say, get out and see the stars at a reasonable time in the evening while you still can before summer comes and we have later and later sunsets. One thing to look for on the equinox itself on the 20th is Venus, along with a tiny sliver of a moon, aka a toenail moon as I like to call it, which will be just above the horizon after sunset. Because Venus is so bright, it is the brightest thing in the night sky after the moon, it should be fairly easy to spot even with the glow of the sunset, but if you're not sure what you're looking for, then at least the moon provides a nice handy little signpost of where to look. They won't hang around long though, setting within the hour after sunset, so the earlier you can look for them, the better. Venus will continue to rise higher and higher after sunset as we get into April, meaning you'll have a better chance of spotting it as the month goes on. Meanwhile, the moon will continue to sweep around the sky on its orbit around Earth before it reaches a half moon phase on the 26th, when it will be smack bang in the middle of Jupiter and the star Pollux in the constellation of Gemini, the twins. And I'm weirdly quite excited for this just because I think it'll look remarkably similar to another nearby triplet on the sky of Orion's belt. This is going to be a really fun one, especially for all you astrophotographers out there. And if you do have telescopes or binoculars, the 26th would be a great night to break them out if it's clear, because you can admire both the moon and Jupiter with very minimal changes to the pointing of your telescope in the process. Jupiter will be very bright, so that should help you pick it out from other nearby stars that will be a lot fainter. Then as we get into April, I'm very excited by the fact that there might be a comet that could get bright enough to be able to see with just our eyes, like no need for binoculars. Comet C/2025 R3 Pan-STARRS will swing past its closest approach to the Earth on the 19th of April on its orbit around the sun, which takes it 160,000 years to get all the way from the Oort cloud on the edge of the solar system and bring it close to the sun again. So because we haven't seen this comet before, we don't have an idea on exactly how bright it actually will get. We're basing it on, other comets that we've seen before. But famously, comets are like cats. They have tails and they are wildly unpredictable. Are you changing my background? Excuse me. How rude. So I've seen predictions that take the brightness of this comet from as faint as Neptune, needing binoculars to see, to as bright as the stars in the constellation of Cassiopeia, the W, which would easily be seen by the naked eye. If over time it does end up getting bright enough to be able to see with just your eyes, I'll pop a comment down below and I'll post a short as well to let you know, so make sure you subscribe so you don't miss that. The comet can be seen in the west just before sunrise in the constellation of Pegasus, so if you do have a telescope and want to try and spot it now, you can do, but fingers crossed that this comet gets nice and bright as it gets closer to the sun, as more of the ice melts off it, taking on that big dusty trail, which is what reflects the sun's light so that we can see it. Hopefully it gets nice and bright so that we'll be able to see it with just our eyes in the sky, because that would be fantastic. Especially because next month I am planning a trip to Joshua Tree National Park, so I'm really hoping to have dark skies to catch this one. Thankfully, the planning for this trip has been made nice and easy thanks to all of the new features on Opera, the sponsor of this week's video. I am one of those people that will just constantly keep opening new tabs on my internet browser, so much so that it just becomes impossible to find anything. So I think my favorite feature of Opera by far is the tab islands. You know, I can group all my Airbnb options in one island. I can then group the recommendations for hikes I've found in another, and then keep it all separate from my research on what I'll be able to see in the night sky when I'm there in another island. I can collapse and expand them, I can name them, and even choose different colors for each one. I've also found Opera's split screen feature so helpful as well. Like, I can have a star chart open on one side while I look at a list of Messier objects I can see from Joshua Tree on the other. I can even split the screen into 4 so I can have my research notes and like the weather forecast open at the same time. Plus, I'm very easily distracted by other apps, so as soon as I swipe away from my browser window, my attention is gone. So I love the fact that I can control my music without interrupting my browsing with Opera's detachable player. I can pop this anywhere inside or outside the browser window. But by far the most useful feature is Opera AI, which has just had an upgrade so that it's smarter, more powerful, and faster. It can help you find sources for information that you read on the web, which is so useful when I'm doing research for my latest night sky news videos. You don't even need to open another tab or have an Opera account to use Opera AI. It's all inbuilt and free. So download Opera today using the link in the description down below. A big thanks again to Opera for sponsoring this video. And now let's come back down to earth and chat about what's been happening in space news in the past month. Now, before we chat about the big Artemis news and the news that hit all the headlines this month, I want to chat about 2 very exciting things that happened for me and my astrophysics colleagues this month. The first one being the start of Rubin alerts. So the Vera C. Rubin Observatory started its 10-year survey of the sky just last year, taking images that cover the entire sky every 3 nights. Once it goes back to the same patch of sky that it was in 3 nights ago, if there's anything that's changed, it sends out an alert. Now, up until now, those alerts had just been sent to the Rubin team, but from here on in, those alerts will be made public to anyone in the world, whether professional astrophysicist or just keen amateur. Now, to make those alerts actually human readable and digestible, there's a number of brokers that actually process the information. Brokers meaning just like a piece of software that takes the raw data from the telescope, processes it, and then plots it in a way that we can actually sort of understand what's going on. On just the first night of public alerts, 800,000 alerts were produced, and the data was available to people roughly 5 minutes after the data was taken. It's quite literally a deluge of data that Rubin is providing. What it means is we've all been having fun clicking through various alerts. In the UK, our broker is called Laser, which I'm showing here. I'll link it down below if you'd like to have a look through some of the data yourself, along with my original video on the Rubin Observatory if you want to know more about this amazing telescope. The second exciting thing to happen this month was that the successful James Webb Space Telescope observing proposals were announced. So each year, NASA puts out a call to the astrophysics community and says, please send us your scientific proposals for what you would like to use the James Webb Space Telescope for. And you have to write a very detailed document justifying the science case and how you'd use it. They all get ranked by a panel, and the top ones get awarded time on JWST and get the data they wanted. I had a quick look through the list of successful proposals to see what jumped out at me. As usual, there's lots of exoplanet science, including many proposals to characterize rocky planets, especially super Earths like 55 Cancri E, which is getting a lot of mirror time this year. Then the ongoing mystery of JWST's little red dots, these what we think are galaxies or perhaps growing supermassive black holes in the distant universe, are dominating all of the galaxy studies. There are 12 separate proposals modules that have all been awarded time to study the little red dots. But there's also a lot of solar system science awarded time as well, with studies on Europa and asteroids in our solar system too. I'll pop a link in the description below if you'd like to explore the list yourself. Alright, on to the news that made all the headlines for what seemed like the wrong reasons this month, and that was the changes to the Artemis missions. So, the original plan for the Artemis missions was that Artemis 2 would take astronauts and orbit them around the moon for the first time in over 50 years, fully testing the Orion crew module for the first time. And then Artemis 3 was going to be the mission that would see astronauts land on the moon in 2028 at the earliest. So, what's the new plan now? Well, there's no change to Artemis 2, which is set to launch very soon, although that's had yet another issue on the launch pad, this time with the flow of helium, so it's been rolled back into the vehicle assembly building and the launch has been pushed back until the 1st of April at the earliest. But what's happened now is there's been an extra mission added between Artemis 2 orbiting around the moon and the old Artemis 3, which was going to land on the moon. That extra mission is now called Artemis 3, with the moon landing mission becoming Artemis 4, but still set to be in 2028. The new Artemis 3 mission will now launch in 2027, and it's to allow low Earth orbit tests of the new lunar landers that are still currently being developed by commercial companies SpaceX and Blue Origin. For those familiar with the early Apollo missions before Apollo 11 became the first to land on the moon, this makes the new Artemis 3 mission very like the Apollo 9 missions, where again they tested the lunar module could fly independently and redock with the command module. I found that there was so much like miscommunication with these changes to Artemis, saying that like, you know, the landing was pushed back to Artemis 4, but really everything's the same, it's just they've added an extra mission in the middle. So hopefully that's clarified that for everybody. Now, it's not every month you see a whole new class of exoplanets discovered, but that's exactly what Nichols and collaborators claim to have found with JWST. So the planet L98-59d was originally discovered by the TESS mission back in 2019, with Kostov and collaborators spotting it in TESS data after it had passed in front of its star, causing a dip in the star's brightness. It's orbiting a red dwarf star, about 30% the mass of the Sun, which is around 35 light years away. The planet itself is 1.5 times the diameter of Earth, but only 2.1 times as heavy as Earth. That means its density is a lot lower, almost half the density of Earth. So when we find a planet like this, we know that it can't be like Earth and Mars, like rock with a lot of dense iron in there. Instead, we think it's got to fall in one of two categories. Either a mini sort of like dwarf gas giant. So like the gas giants of Jupiter, Saturn, Uranus, and Neptune in our own solar system, but on a smaller scale. Or it's a water world, because water is a lot less dense than rock. So you have something like an icy crust with deep oceans underneath it. So because people get very excited by water worlds, the Hubble Space Telescope took a look at its atmosphere to see if we could figure out which one it was. You do this by waiting for the planet to pass in front of its star, and then you isolate the tiny bit of light that passed through the atmosphere of the planet to record the fingerprints left on that light by the elements and molecules present in the atmosphere. And by doing this, Zhu and collaborators with Hubble ruled out a sort of hydrogen helium gas giant-like atmosphere. So the thought was that that sort of then confirmed that L98-59d had to be a water world. Until JWST observations published by Gressier and collaborators revealed that the atmosphere didn't contain any water, and instead most likely contained a bunch of sulfur molecules like sulfur dioxide and hydrogen sulfide, which means this planet probably doesn't smell very nice.
And really bad eggs.
So what is going on? Well, Nichols and collaborators have used a computer simulation to model the formation and evolution of this planet to try and recreate its sulfur-dominated atmosphere on a planet of this size and mass in order to essentially match it to the observations that we have. They showed that these sulfur gases can be created in a planet's atmosphere if UV light from the host star comes in and hits into molecules, triggering chemical reactions. But usually those gases would then have so much energy after being hit by that radiation that they would be slowly lost to space. But if this planet has a global magma ocean dropping kilometers below a silicate crust, so like a lava ocean essentially, that can act as a reservoir that replenishes the sulfur in the atmosphere over billions of years. According to the simulations, L9859d likely formed with a very large amount of hydrogen, meaning it was once like a mini Neptune, but then over billions of years it gradually shrank as it cooled, lost some of that hydrogen atmosphere, and was enriched by the magma ocean with sulfur. And because this is unlike anything we've ever seen before when it comes to exoplanets, Nichols and collaborators suggest this could be a whole new class of exoplanet. Sulfur-rich planets with magma oceans that stick around for billions of years. It kind of makes you wonder, like, what other types of exoplanets could just be out there in the universe just waiting to be found. And finally, let's talk about some new results from NASA's DART mission, which showed material transfer can occur between two asteroids. So why is this a big deal? Well, as a reminder, first of all, the DART mission was the test to see if we could change an asteroid's orbit by crashing something into it. Why would you even try to do that? Well, if there is ever an asteroid that is a danger to Earth in terms of a very likely impact scenario, then to avoid that, you don't need to send like nuclear weapons or Bruce Willis up into space. All you need to do is just give it a little bit of a nudge just to change its orbit ever so slightly so that it means that as Earth moves along its orbit and the asteroid moves along its orbit, they're no longer going to intersect, they're just going to miss each other. So if that is our in case of emergency break glass plan, then we need to be able to test it. Hence the DART mission. Now NASA chose a binary asteroid for this mission, crashing into Dimorphos, the asteroid moon orbiting the larger Didymos. And from how much Dimorphos's orbit changed, we can work out how much energy was transferred in the crash, and then we can know, okay, well that's how much energy we can transfer, so if we were going to do this on a bigger asteroid, how much of a nudge would we actually be able to give it? What's exciting though is what Sunshine and collaborators spotted in the images taken of Dimorphos right before the impact. They noticed a strange fan-like pattern in the images. Now, sometimes things like this just end up being like tricks of the camera that aren't real. They're either due to like the weird shadows that you get in space because there's like no atmosphere and the sun's coming from a strange angle and things like this, or they're just like weird like aberrations in the lenses in the camera equipment itself. So the first thing Sunshine and collaborators did was try to prove it wasn't real, but when they couldn't find an artificial source for this fan-like structure, and after removing all the shadows caused by boulders in the image, and it was still there with all the rays converging near the equator of Dimorphos, they were slowly convinced that what they were seeing actually was real. So if it's real, then what caused this? They considered asteroid quakes, you know, kind of like an earthquake, but that wouldn't actually account for the weird fan-like pattern that you're seeing. They also thought about like static on the dust on the surface of the asteroid, but you couldn't really explain again that fan-like pattern with static. You won't be able to shepherd it into that pattern. So after doing some physical experiments, firing boulders at dust piles in labs here on Earth, and also after running some simulations, they concluded that the most likely explanation for this fan-like pattern was a low-speed impact into a field of boulders on the surface of Dimorphos. Essentially, it's being hit by a load of big dirty snowballs that are fired off by the bigger asteroid that it's orbiting, Didymos. That means that this is the first direct evidence of material being transferred from one asteroid to another. And that is a really big deal. If you watched my video from last week on the science behind Project Hail Mary, which I promise doesn't have any spoilers for the film, you'll have heard me talk about the idea of panspermia, the hypothesis that all life in the universe might have a common origin and has spread from star system to star system by hitching a ride on things like asteroids, comets, or maybe even microscopic dust particles. So this work by Sunshine and collaborators isn't a direct proof of panspermia by any stretch of the imagination, but it is one big step closer to this idea of panspermia becoming more likely in reality. Alright, that's it for Night Sky News for this month. As always, if you spot any space news stories that you want me to explain in a future Night Sky News video, or if you snap any pictures of the night sky, then tag me over on social media because I would always love to see those. I'm going to be in Joshua Tree next month, so fingers crossed for clear skies. I think the likelihood is greater than here in the UK anyway. But until next time, everybody, happy stargazing. Alright, cool. Alright, you gonna stay there for me? You're just gonna have a pit butt the entire episode. She's got a little Norwegian ridgeback, I always joke, here. So no, you can't see her. There she is. Okay, if I do that, and I shove this in a little bit, and I nudge myself this way, you'll be able to see Pip while I chat. Because that's what everybody wants, right? They don't want to see me, they want to see the cat.